Today we're going to start with the chapter Arithmetic. So I've divided arithmetic into 4 sections for your ease, and that's why you can watch all 4 videos in a go. So Arithmetic 1 includes number operations, decimal places, squares, and square roots, which is pretty easy. In number operations, these are all the subtopics that we're going to cover, and in decimal places, the only 2 things we're going to cover is equivalence and conversion. So types of numbers. Numbers. What is a number? How do I define different types of numbers? So firstly, you can see this whole large Venn diagram, and over here I have this huge category of real numbers. And a real number is any number. It could be 1, it could be 2, it could be -3, it could be 4/5. It can be any number that you wish. It could be under root 6, it could be 7.8, and in this manner, any type of number you can think, it's going to be a real number. Then, an irrational number. Amongst real numbers, you have 2 subcategories, and irrational numbers and rational numbers. So what are irrational numbers? They're numbers that cannot be expressed as a fraction. For example, under root 3. And then the other category is rational numbers that can be expressed as a fraction. For example, 3/2 or 2/1, which is simply 2. And then you have integers. Integers are a subcategory of rational numbers. Rational numbers can be expressed as a fraction, but an integer is neither a decimal nor a fraction. Technically, if you look at that, you can convert it into a decimal or a fraction. For example, 4.0 or 4/1. But when you simplify them, you're going to get an integer, not a decimal or a fraction. And then within integers, you have this category of whole numbers. And whole numbers are non-negative numbers. For example, 0. A whole number is any number that is 0 or greater than 0, which means it's equals to or greater than 0. It could be 0, 1, 2, 3, and so on, but it cannot be -1 or -4 because the definition of whole numbers is any non-negative number. And then within whole numbers, you have the category of natural numbers, and natural numbers are simply greater than 0, for example, 5. So the only difference between natural numbers and whole numbers is that whole numbers include 0 and natural numbers do not include 0. So in this region of whole numbers where you do not have natural numbers, the only value that you have is 0. And over here, you'll have 1, 2, 3, and so on. And these values are also going to be included in whole numbers as well as natural numbers, but 0 will only be included in whole numbers. Okay, then we have LCM and HCF. LCM is the lowest common multiple, and HCF is the highest common factor. What do I mean by the lowest common multiple? If I'm taking 2 numbers, I want a multiple. I want a number that is a multiple of all of them, but I want the lowest value out of all the multiples common. So if I have 120, 144, 160, and 180, and I want a number that's a multiple of all 4 of them, so I'm going to take out their LCM, and how will I do that? I will first take out the first prime number that is common between all 4 of them. What are prime numbers? Numbers that do not have a factor, or numbers that have only 1 as their factor or divisor. So what's common between 120, 144, 160, and 180? First, we have 2. And so we divide 120 to 60, and so on. So we have 60, 72, 80, 90. Once again, the first common prime number is 2. And then once again, 2, 2, 2, and then it's 3. And then when we've divided all 4 of them by 3, now we have another common number 3. And once again, when we divide all these values by 3, we have 5, 3, 5, and 15. But 5, 3, 5, and 15 have no value, no prime number that is common in all of them. So first I'm going to take the smaller one, that is 3, and I'm going to divide 3 and 15 by that, and I'll let the 5 and 5 stay as it is. And then I'm going to divide it by 5 so that I get all ones. And in that way, I'm going to get all ones. And so I've completely divided all these 4 numbers. By what did I divide them? I divided them by all these values. And since I consecutively kept on dividing them by all these values, I'm going to multiply all these values together to get my LCM. So 2 into 2 into 2 into 2 into 2 into 3 into 3 into 5. Or we can also express that as 2 to the power 5 into 3 square times 5, and the number we get is 1,440, which is the LCM for all these four values. Next, we want to find out the highest common factor of 45 and 60, the largest number that can divide 45 and 60. So we'll just look at the black numbers and we're going to ignore the red numbers at the moment. And so what's the common prime number between the two of them? 3. So I divide both of them by 3 to get 15 and 20, then divide them by 5 to get 3 and 4. Now there's no common prime number between 3 and 4, so I'm going to stop here. Over here, when I was taking out the LCM and there was no single common number in all these values, I first took 3, which was common in 2 of them, and then I took 5, which was common in 2 of them, and to get my LCM to get all four ones. But in HCF, you don't want all four ones. You want the lowest two values that do not have any prime number in common. So I get 3 and 4. And so I'm going to multiply 3 and 5, 15. And 15 is the largest number that is going to divide 45 and 60. So when I divide 45 by 15, I'm going to get 3. And when I divide 60 by 15, I'm going to get 4, as shown over here. And so 3 times 5, 15 is my HCF, but say I want to find the LCM of 45 and 60, the lowest common multiple between these two numbers. So I'm going to take it all the way to 1, 1, and when I have 3, 4, I'll just take the smallest one first. So I'll take 3, I'll divide it by 3, and I get 1 here. I'll let the 4 stay as it is, then I'll take 4, and I'll get 1, 1, then I'll multiply 3 with 5, and that 5 with 3, and that 3 with 4 to get 180, because 3 squared times 5 times 4 gives me 180, which is the LCM for 45 and 60. That's LCM and HCF, and that's something very, very easy, something we all already know. Then we have fractions. So the first type of fraction is vulgar. There are two types of fractions, vulgar and decimal fractions. Vulgar fractions are those that can be expressed in the form a upon b, and decimal fractions are those that can be expressed in the form b point c. And so in decimals, we have equivalence and conversion. For example, if we have 0.6, so how can I convert 0.6 into a fraction? It's 2 upon 3. Or how can I find a value that is equivalent to 0.6? Then, in vulgar fractions, we have several different types of fractions. The first type is mixed fractions, which is when you have a whole number and another fraction along with it. So that becomes 1 whole, 1 upon 2. Then we have proper fractions. Proper fractions are those that are simply expressed in the form a upon b, and a is smaller than b. So here you can see we have 4 upon 8 that can be simplified to 1 upon 2, and in both the cases, the denominator is larger than the numerator. But in an improper fraction, the numerator is larger than the denominator, for example, 54 upon 6. Next, we have squares and square roots. So whenever I'm finding the square root of a number, always I need to remember it could be a square root or a cube root or any other under root. Whenever I'm finding the root of a number, my value can also be positive and it can also be negative. So under root 9 could either be plus 3 or negative 3, because if I square 3, I'm going to get 9. And if I square negative 3, I'm going to get 9 as well. Then, if I have a value termed as 18 to the power 3 upon 2, how can I simplify that? The top number, the numerator, is going to stay with the number, so the cube is going to stay with 18, and the 2 is going to go in under root. So I have the square root of 18 cubed, which comes out to be 76.4. Then, any number to the power 0 is 1. Any number. It could be 2 to the power 0, it could be 3 to the power 0, it could be 2 plus 5x whole bracket, whole to the power 0, and every single value is going to come out as 1. And anything to the power of 1 is itself. 18 to the power 1 is 18, 2 to the power 1 is 2, 3 to the power 1 is 3, 564 to the power 1 is 564. Then we have symbols. What's the first symbol? That's the equals to sign. We all know that. This is the not equals to sign. The equals to sign with a slash across it is the not equals to sign. So if I say 3 is not equals to 2, I'm going to use this symbol, and my equation is going to be correct. Then this is the greater than sign. How can you remember that? You can remember that because this greater than sign can make a G. And so that means greater than. If I want to say that 2 is greater than 1, I'm going to use this symbol. Then I have the less than sign. How can you remember that? That can make S, which is S for smaller. So this is greater than, and this is smaller than, or less than. And then I have less than or equals to. Less than or equals to means that your number could be less than a value or equals to that value. I am correct in saying that 1 is less than or equals to 1. Because yes, 1 is equals to 1, and so the symbol is fulfilling that expression. Or I could say greater than or equals to.